Welcome back to Spice. In this session, we'll focus on a new topic, OPC, Object Linking Embedding for Process Control. So that is the old name, OPC, OLE for Process Control, Object Linking and Embedding for Process Control. But just want to inform you, the latest name is Open Platform Communication. The OLE for Process Control was the previous name. And as per my understanding, now we are calling this as an Open Platform Communication. Okay. So this is the look and feel of the OPC server and OPC client here. And it gathers data from the field, PLC DCSs. Okay. So what is the main purpose of the OPC? See, OPC is mainly used in manufacturing industry for process control, right? So it provides a uniform interface for controlling devices and allowing communication between devices from different manufacturers. So that is the advantage. So you basically want to fetch the data from here. So OPC is used as a communication. Okay, good to go, friends. Right. So now I'll go into a bit of an intro first. OLE, Object Linking Embedding for Process Control. Okay. So the acronym OPC comes from OLE, Object Linking and Embedding for Process Control. This we all know. So basically this OPC is based on a distributed component object model. We call it as a DCOM technology. Basically, it's a Microsoft technology that allows components of software to communicate in a network environment. That is the concept here. Okay. So OPC comprises of many items like, OPC data access. We call it as a OPC DA, and OPC unified architecture. We call it as a OPC UA, and OPC historical data access, that is called as OPC HDA, and OPC alarm and events, that is OPC A&E. There are many aspects many things OPC comprises of all these actually. So I'm going to explain this in detail in the next session, wherein I'm going to focus on the question and answer on all aspects related to OPC. Okay. So probably you can, want to, get to know more about this, you can watch that next video. Okay. We will limit this explanation to this actually, just for what is what. Okay. Because the question and answer is going to come in detail. So that will help you actually. Or maybe if you want to, touch upon something, I can touch upon here also, but that will take the discussions to a different, different, different aspects. Okay. Probably I can cover. Okay. What is this OPC DA? So basically, this DA stands for OPC data access, right? So which is a group of client service standard that provides a specification for exchanging, what is that? Real-time automation data between PC. So that is the point. This is data access. This is real-time data between PC. Okay, that is one thing. Then what is OPC UA? So basically, this is unified architecture. Again, it's a platform independent service oriented architecture that integrates all functionality of the individual OPC classic specification into one extensible network. This is called OPC UA. It is basically a platform independent service oriented architecture. Okay. So that is the OPC UA. There are many things like which protocol they use. Actually, OPC UA use actually HTTP, Hypertext Transfer Protocol for data transport. So those things will be covering in a later part. Okay. Then what is this HTA, Historical Data Access? Basically, this enables access to historical process data. So that is the purpose. Then what is this A&E, alarm and events? Yeah, again, it stands for alarm and events, which provides an alarm and event notification. That's it. As simple as that. Okay. So let's move on further. OPC generally communicates OPC generally communicates information from a data source such as server, right, friends, to any client application in a standard way without requiring the application to have any specific knowledge about data source. That is the point. Okay. OPC generally communicate information from a data source such as a server to any client application in a standard way without requiring the application to have any specific knowledge about the data source. That's the point. So OPC is an interoperability standard for the secure and reliable exchange of data in the industrial automation, right? Good. Few more to add on the intro part. So it is basically a platform independent, which I highlighted earlier, and ensures the seamless flow of information among devices from multiple vendors. That is the beauty, multiple vendors. So OPC standard is a series of specification developed by industry vendors, okay, yeah, users and end users and software developers, not end user, yeah, end users and software developers, okay. So, yeah, this specification define the interface between the client and server, including the access to real-time data, monitoring of alarms and events, and access to historical data and other applications. These specifications, okay? So the standard was released in 1995-96 to abstract PLC-specific protocol, like, Modbus, Profibus into a standardized interface. What for? Allowing the HMI and SCADA system to interface with a middleman who would convert a generic OPC read-write request into a device-specific request. You got it, friends? So it was released in 1996 to abstract the PLC-specific protocol into a standardized interface. That's a point actually, for allowing HMI SCADA system to interface. Okay, good. So that's about the intro. Now I have some questions or maybe challenges related to the OPC. Why this OPC came into picture? That's I just want to go back a little bit. Okay, so there is a problem related to the custom drivers. See, if you look at the picture, you see the PLC, you see the DCS, right? RTO all there. So it is communicating here through this various drivers, custom drivers. So that is the challenge here. But whereas if you see here, so this is your PLC, all this, right? And this is what your, HMI, all this, and how it is communicating through OPC. See, you have individual custom drivers here, all are replaced by OPC. So that is the beauty of this. I hope you got it, right? Okay. Each application requires a device or protocol specific driver to allow you to communicate with a respective device. So that was a challenge. So the drivers here are not reusable between application because each application uses its own data format, and this challenge is solved using an OPC. You got it? Yes, that is the beauty of this OPC. Okay, now OPC is a server client. Okay, server client. So it can be in a single PC also. Okay, right. So OPC server is a software program that converts the hardware communication protocol used by the PLC into OPC protocol. Very simple. OPC server is a software program that converts the hardware communication protocol used by the PLC into the OPC protocol. So OPC client software, okay, is any program that needs to connect the hardware such as HMI. Okay, you got it, friends? OPC client software is any program that needs to connect the hardware, okay, such as HMI. Okay, right. So OPC client uses the OPC server to get data. OPC client uses OPC server to get data from or send commands to the hardware. Very simple. So hardware manufacturer need only to provide a single OPC server for their device, a single OPC server for their device to communicate with OPC client. Good to go? Yes. Now, few more to add on. Software vendor simply include OPC client capability in their product. You would have known, right? Yes, ours is OPC client capability. Yes. So they have to include OPC client capability in their products, and they become instantly compatible with thousands of hardware devices. As simple as that. End users can choose any OPC client software they need, assured that it will communicate seamlessly with their OPC-enabled hardware and vice versa. You got it, friends? Got it. Okay, good. So that's about the thing, and few more actually. Yeah. Typical OPC connection scenario is a single server client connection on a single computer as shown. But there are more possibilities. What are all those? These are the additional features I want to tell you. Additional, yeah. Connect the OPC client to several servers. OPC client to a several server. So that concept is called OPC aggregation. Aggregation. Okay. Then connect the OPC client to an OPC server over a network. Then that is OPC tunneling. Connect the OPC server to another OPC server to share data. That is OPC bridging. So these are the some of the possibilities. Okay. Maybe configurations, right? And another aspect also I want to talk about. There is a OPC data hub. This is uniquely designed to do all these. What is that? Whatever we have seen, right? Tunneling, aggregation, bridging, all these. Okay. So basically, what is OPC data hub? It is a combination of OPC server and OPC client that supports multiple connections. So that is the point. So it can connect to a server it can connect to server OPC server for aggregation, bridging to OPC data hub, mirror the data across the TCP network to provide OPC tunneling. You got the meaning, right? So this data hub can connect to server of the OPC server for aggregating, okay, bridging to OPC data hubs for what? For mirror data, mirroring the data across the TCP network. Okay. I think there is a typo error here. So it can connect to OPC server. We have to read like that. So in addition to enhancing the OPC server and client connection, OPC data hub can connect any OPC server or client to other application as well. What are those? Excel, web server, or any database? That is also possible actually. So with that, I want to conclude that there are the few more actually. Friends, OPC was designed to provide a common bridge for window-based software application and process control hardware. So basically designed to provide a common bridge for the window-based software application and the process control hardware, PLC like that. So OPC server for one hardware device provides same method for OPC client to access its data any and every other OPC server for that same and any other hardware device. I hope, I don't know whether you got it. See, the point is an OPC server for one hardware device. One hardware device provides same method for an OPC client to access any data on every other OPC server. That's it, friends. Don't get confused. Okay, right. So the aim was to reduce the amount of duplicated effort required from the hardware manufacturer and their software partner and from the SCADA and the HMI producer to interface. That's the point. Okay, right. So once the hardware manufacturer develop their OPC server for a new hardware device, their work is done. Yes, I'm done with that. So it can allow any top end to access their device. And similarly, once the SCADA manufacturer developed their OPC client, their work was done to allow access to any hardware. That's it. Very simple. Finished. That's all, friends. This is all about the OPC. This is more on the what do you call that? Some concept related. Now I'm going to take you through the question and answers, which is very vital. Stay tuned. See you in the next video. Thank you. Take care. And if you feel that this video is useful to you, can show your support by pressing the thumbs up button, and if possible, subscribe, and if possible, become a member to show your solidarity for the for our all our efforts. So far, we have uploaded around 270 plus videos, friends. Just watch and get benefited. All for you guys. Okay. Thank you. Take care. Bye.